Today we're looking at something called implicit differentiation.
What?
Implicit differentiation is what we're looking at today.
Okay.
That means that we've been doing some differentiation that wasn't implicit. So what word do you think we've been doing besides implicit?
Non-implicit.
Explicit differentiation.
Differentiation.
We've been doing
Okay? And if you notice, if you look at these examples up here that we're getting ready to do, first one, x squared minus y squared equals 16. I've got x times y plus y equals 9. I've got x squared y plus xy squared equals 2x. I've got y plus the square root of xy equals 4. What's different about those than what we've been used to working with? Chelsea?
You have an equal sign?
What?
You have an equal sign.
We've been doing stuff with equal sign.
I haven't been paying attention.
There's two variables.
We've always had two variables.
Yeah.
A variable.
There's
On everything we've done, it's always been y equals or it's been f of x equals. But in this case, what do you notice about the y?
It's in the different.
Everything's all mixed up and y is not by itself.
Do we have to make y by itself?
We do not have to make y by itself. That's the nice thing about implicit differentiation, is that I can take the derivative of this without getting y by itself. Okay? So explicit differentiation is when I have one variable by itself and I'm taking pretty much the derivative of the other side. In this case, I've got the x and the y's that are mixed together, and so I have to use implicit differentiation to do that. Okay? Now, if I didn't use implicit differentiation, which you don't know how to do yet, what would I do to find the derivative of x squared minus y squared equals 16?
Get y by itself.
I would have to get y by itself, and that would require me to do what?
Algebra.
Yeah. Algebra.
In the process of getting y by itself, what would I have to add?
You would plus or minus.
The plus or minus, okay? And the plus or minus messes with us, and we can't find the derivative when we're dealing with plus or minus, okay? So that's why we want to do differentiation, or implicit differentiation, okay? Here's how it's done. I'm going to show you. I'm going to go ahead and do it, and then we'll come back and talk about what I did. All right, so I'm looking at x squared minus y squared equals 16. If I take the derivative of that, that's going to give me 2x dx dx minus 2y dy dx, and then the derivative of 16 is going to be 0. That is implicit differentiation. All implicit differentiation is when I take the derivative of y, I have to put dy dx behind it. When I take the derivative of x, I have to put dx over dx behind it. If you can keep track of that, anytime I take the derivative of something with y, put dy over dx. Anytime I take the derivative of x, put dx over dx. That is implicit differentiation. Just keeping track of what variable you're taking the derivative of.
Why did they change to 0?
Because the derivative of a constant is 0. Okay? Now, notice, what is dx over dx?
1.
It's 1. So I have 2x.
Why do we have to write that?
Why do we have to write what?
The letters.
I'll tell you in just a second. We have to keep track of what we're taking the derivative of. Okay? And we always take most of the time, take the derivative with respect to x. Alright, we take the derivatives with respect to x. That's why the dx is on the bottom, because that's what we're taking the derivatives with respect to. The top is what we're taking the derivative of. So on this first one, I was taking the derivative of x squared, which involves an x, so that's why I need the derivative of x with respect to x. On this one, I was taking the derivative of y, so that's why I need dy over dx. Now, the dy over dx should look familiar to you. What does dy over dx mean?
The derivative.
The derivative.
Well, isn't that what that means?
That just means derivative.
So why is
dy
it?
over dx represents the derivative, yes.
I didn't know that.
Yes.
Why is it
What
dx
are
over
we
dx
writing on
instead
the
of
first
dy
one?
over dx?
Okay, Rick wants to know why on this first one is it dx over dx instead of dy over dx?
Because we're getting derivative.
Because I was taking the derivative of x. not y. Over here, I was taking the derivative of y, so that's why it's dy over dx.
Why wouldn't it be dy over dy?
Because I'm taking it with respect to x. It's a funky, you don't have to understand it, you just have to know that we're taking with respect to x. So, I don't know, I got a little infection or something going on. Anyway, now, in this particular case, they're wanting dy dx at this particular point. So once I get to this step, what do I want to do?
Plug it in.
Plug it in. And notice, every derivative we've been doing up to this point, we've only been plugging in what? The x value. Now we have something to plug the y value into. So I'm going to plug the 5 in here. That's going to give me 2 times 5. I'm going to plug the negative 3 in here. And then I still have my dy dx. Alright? And if you notice, the directions say find dy dx. So what do I want to do?
Get dy dx by itself.
Get dy dx by itself. So this is going to be 10. Let's go ahead and subtract that to the other side. So I'm going to have minus 10 over there. This gives me 6 dy dx. And then when I divide, I get negative 10 over 6. And what do I have in dy dx equals negative 10 over 6? The derivative at
5 negative.
5 negative 3. Okay? When I plug something into the derivative, what also does that represent? My slope. So that is the slope of what?
The tangent line.
The tangent line at the point 5 negative 3. Alright, let's try the next one. The next one is xy plus y equals 9. xy plus y equals 9. I'll write it bigger.
So we would get it wrong if we got y by itself and then did like another rule.
You can't get y by itself. A lot of these you won't be able to get y by itself. This one, you can get y by itself. But some of them, like on number 4 down there, you can't get y by itself. So that's why you've got to do implicit differentiation.
Okay.
All right, so when I take the derivative of xy, what is that going to require? The product rule. Okay, Brooks, what's the product rule again?
It's first times derivative of the second plus second times derivative of the first.
All right, so very good. So on this right here, the first is going to be x. What's the derivative of the second going to be?
dy over
dy over dx. Okay. Plus the second, which is y, times the derivative of the first, which is... And right now, we're going to go ahead and continue to write dx over dx, just to get used to it. Eventually, I won't require you to write the dx over dx.
And what if we just plus?
Plus, now I need the derivative of y,
Dy over dx.
dy over dx, and then the derivative of 9 is 0. That's implicit differentiation.
And then you have to get it by itself, don't you?
Not yet.
I mean, I know it's kind of already answered, but the dy over dx or whatever it is, it didn't attach to the variable that comes before it.
It is. They're multiplied times each other.
Why can't you just
So
write
this is multiplied
But
times
I
this.
mean, they don't have to stay together. is what I'm asking.
No, but if you want to get rid of it, you're either going to have to factor something or divide by something.
why
It's
can't
not
you
like
just-
f with x or whatever.
Right. They're two different things.
Can't you just write y prime and x prime?
You can't. Okay, but eventually we're not going to write x prime. Eventually I'll let you write y prime instead of dy over dx.
Okay.
But right now I want to use this to understand what we're doing.
Okay.
All right, so once I get to this point, what do I want to do?
Okay.
I want to plug in. My point is 2, 3. So I plug in 2 for x. I plug in 3 for y. And what happens to this dx over dx?
It goes away.
It reduces to 1. And then I have plus dy over dx equals 0. So obviously I'm going to subtract 3 over. I have 2 dy dx plus dy dx. What does that give me?
3.
3 dy dx. And then all I have to do is divide.
This equals dy.
So I get dy over dx equals -1. Now again, what do I have there? Dy dx equals -1. Over the tangent line at the point 2,3. Very good. Number 4 is y equals this, not y equals, y plus.
What you did show.
Got me messed up. Alright, I have y plus the square root of xy equals 4. We want to find the derivative and plug in the point 2,2.
So y dy over dx is the same as y prime.
dy over dx is the same thing as y prime. That is correct.
All right.
Alright, so when I take the derivative of y, what am I going to get? dy over dx. Now, what do I want to think of the square root of xy as? X to the 1/2. So what do I have to take care of first? The 1/2. The inside stays the same, and my new exponent is -1/2. So that takes care of the outside.
What's the derivative of the inside?
Now I need the derivative of the inside. What's the derivative of the inside going to require? Product rule. So I need the first, which is x, times the derivative of the second. What's the derivative of the second?
dy over dx.
dy over dx. Plus the second times the derivative of the first. What's the derivative of the first?
dx over dx.
dx over dx. And then that equals the derivative of 4. 0.
Is it always going to equal 0?
Well, if I'm taking the derivative of a number, it's always going to be 0. But if something over there with a variable, like on this number 3 that we didn't do, there's a 2x over there, so it's not going to be 0. It'll be 2.
So what exactly are we doing?
We're taking the derivative.
Okay.
When we're dealing with a curve and the x and y's are intermingled. Beforehand, the y has been over there on the left and the x's have been over there on the right, so it's been pretty easy. Now they're mixed together.
So this is just like a different way to find the derivative of like a different equation. Kind of.
It's different equations that we've been dealing with, yes.
Okay.
All right, now before I plug in 2,2, I have to do one more thing. What do I have to do before I plug in 2,2? Take care of this negative. So I have dy over dx plus, what's going to be on the top? X dy dx plus, now this is going to reduce to 1, so that's just y. And that's over 2 square root of xy.
Oh my
Did that just blow you away?
gosh. Yeah. What? Oh. Oh.
So
okay,
would
I got it now.
X, Y, because, I mean, it would be 2 square root of x, y because of that negative on the top, I mean.
Yes. If that negative was a positive right there, yes, everything would have been on the top. But since it's negative, that means it's got to go to the bottom. All right, once I get to this point, now I can go ahead and plug in. So notice I'm plugging in 2 for the x and the y, so that should make it pretty easy. So that's going to be 2 dy dx plus 2 over 2 times the square root of 4. All right, so 2 times the square root of 4 is equal to 4. So what's the easiest thing to do next? Multiply everything by
Yeah.
4 is what I would do. But yeah, I see what you're saying. You can cancel the 2.
Okay.
So I get 4 dy over dx plus 2 dy over dx plus 2 equals 0. Right with me there?
So if we just cancel the 2 and make it over 2, you don't have to do the whole 4 thing in front.
Well, if I did that, then this would cancel these.
No, after you did that, you cancel it, reduce the 4 to 2.
then this would become 2, and I'd still have to multiply everything by 2.
Oh, so you can
So one way or another, you're going to have to multiply.
What do we multiply that for?
We multiplied by 4 because I need to be able to put this dy dx with this dy dx. So I have to get rid of that. Yes?
Could you have Brett Chase come down to the main office and bring his car keys, please?
Good. Alright, so 4 dy dx and 2 dy dx give me 6 dy dx. And I move that 2 to the other side, and that gives me a -2. So I get dy over dx equals -2. 6 is fine. If you want to be a rebel, and make it -1/3. That's
Why
also.
is that a 2 right there?
Why is what a 2?
The 4 dy dx plus 2 dy dx, why is that a 2?
This 2?
No.
This 2.
Yeah.
This is that 2.
But then you have to multiply.
I did 4 times this, gave me that. 4 times this whole thing right here is going to cancel with the bottom. Because this bottom right here equals 4. So 4 times this fraction, those 4s are going to cancel, and I'm just left with what's in the numerator.
Okay.
No, what is on the right?
Where?
Like what you just wrote.
Here?
Like all that.
Well, I moved this. Yes, I'm just continuing.
Oh.
Is all I did. I moved the -2. I moved the 2 over. I put the 4 and the 2 together to get 6, and then I divide it. All right. Now, what does that represent? The -1/3. What does the -1/3 represent? Slope of the tangent line at 2, 2. Very good. 7. Now this time, do you notice? Do we have anything to put in?
Yeah.
No. Since we don't have anything to put in, and they want me to find dy dx, what am I going to have to do at the end?
Wait, you're here?
No.
Just leave it on.
No. Well, let's. No.
No, I don't know.
All right, let's do it, and then we'll figure it out. So I have sine of x times y equals 1. So what do I have to take the derivative of first?
Sine.
Sine. What's the derivative of sine? What's inside of cosine? xy. Okay. I have to multiply that times what?
Inside.
Derivative of the inside. What's required for the inside? So I need first times the derivative of the second. Plus the second times the derivative of the first. Alright, and then that equals the derivative of 1, which is
0.
0.
Yes.
So, if they're wanting me to find dy dx, they're wanting me to do what with dy dx?
Get by itself.
Get it by itself. Alright, what do you want to do next?
Multiply by cosine. Divide by cosine.
Alright, now I cannot divide by cosine xy.
Dang.
Because why?
Because
I would lose a variable. You cannot divide if you're going to lose a variable. Because if I divide by cosine xy, 0 divided by cosine xy is 0. I would lose this. I can't lose variables. I can only lose numbers. So, instead of dividing, I need to go ahead and multiply that through. So that's going to be x cosine xy dy dx. Plus, remember this goes to 1, so that's going to be plus y cosine of xy. Alright, all I did was distribute the cosine xy. I can subtract what? When I want to subtract that one over, if I'm trying to get dy dx by itself. So I'm going to subtract that to the other side. And then all that's left is to divide.
So what did you do?
All right, Noonie, what was your question?
What did you do after?
What did I do to get here? I just took this right here times that, and I took it times that. And remember this dx over dx is gone because that's equal to 1. So now I've got dy dx by itself, and that's what the problem wanted me to do. All right, what's different about 8?
You had to find simplify or
Oh, you have to find
What is that asking me to find?
the derivative.
Second
Yes, that represents the second derivative.
Oh my.
Okay? So, yes.
Why is the squared in between d and y on the top?
That's a good question. Everybody I talk to says that's because whoever came up with it, that's the way they wrote it. There are two different math guys that came up with it evidently at the same time. One of them wrote it like that, another one wrote it a different way. Well, whoever wrote it like that won out, and that's how everybody writes it. That's what I've been told.
That's what dumb thing.
So, what would I have to do on this? The first step would be to
Find the derivative.
find.
2x plus.
All right, let's go ahead and do it. Let's go ahead and do it. So that would be 2x dx plus 2y dy dx, and then derivative of 100 is 0. All right, so that right there goes to 1. Now, before I can find the second derivative, what do you think I need to do?
You get the
Get the first.
Get dy dx by itself. So I want 2y dy over dx equals negative 2x. And the dx canceled. All I did was subtract the 2x over. And now I want to divide by the 2y.
What happened to the? Okay, no.
So dy dx is just negative x over y. And then all I have to do is what? Second derivative. So the second derivative, what do I need to do for the second derivative of that? Quotient rule. What's the quotient rule again? Bottom derivative of the top, so negative 1 dx over dx minus the top, which is negative x, derivative of the bottom, which would be dy dx
all over the bottom squared.
all over the bottom squared. Okay, this is what I'm looking for. But if you notice, the dx, that right there goes to 1. But if you notice over here, I've got a dy dx. What do I do with the dy dx? Very good. Alex says, if you look here, I know that dy dx is negative x over y, right? So I plug it in. So I'm going to have y minus 1 plus x times negative x over y squared. Okay, and that's close to an acceptable answer, but it's not close enough.
Why is there a y minus negative 1?
Because I have a y and I have minus 1.
That's a
Shouldn't it be negative y then?
That's multiplied? Okay.
Yeah.
That's good, thank you. So that I should have put parentheses right there then. So that's negative y. Thank you. Alright, I'm not happy with this answer because why? Fraction is a fraction, so all I need to do is multiply by y. So that means my final answer would be negative y squared minus x squared over y cubed. Alright, let's just talk about 9. Find the equation of the tangent line to this at this point. The equation of a tangent line tells me to do what? Find the derivative,
Then find the slope.
find the slope, and use my point, and then write my equation. So, I find the derivative, I plug in to get my slope, I use that slope with this point to write the equation of my line, which we need to be getting close to being a pro at.